All right. So 6.4, trig students, we will begin part one by looking at the right triangle definitions of the six trig functions. To begin with, in any right triangle, of course, there's only one right angle, and then there are two acute angles. So we'll be focusing on the ratios that exist in the triangle. And the longest side of the right triangle is called the hypotenuse. And we know the Pythagorean theorem is the relationship between the three sides, a squared plus b squared equals c squared. Okay, the other two sides opposite the acute angles are called the legs. Okay, just a couple of things for naming. This is kind of the naming convention. We use uppercase A, B, and C as the angles, lowercase a, b, and c for the sides. C is always represented as the right angle. C is the hypotenuse, and that's lowercase c. And then A and B would be the other two angles, the acute angles then. So what we have is, it turns out that if you matched up a ratio of two sides in a triangle, there's 6 ways to do it. So there are 6 trig functions that we define, and they're defined by these ratios. So the sine of theta, theta being an angle, and this is going to be one of those acute angles in the triangle, it's defined to be the length of the side opposite over the length of the hypotenuse. The cosine is the length of the side adjacent, theta, divided by the length of hypotenuse. And then the tangent is the length of the side opposite over the length of the side adjacent to the angle theta. Then you kind of get into these reciprocal relationships. You'll notice the sine and cosecant are really just reciprocals of each other. The cosecant is the length of the hypotenuse over the length of the side opposite. The secant is the reciprocal of the cosine, so it's hypotenuse over adjacent. Then cotangent turns out to be the reciprocal of tangent, so it's the length of the side adjacent over the length of side opposite. And those are everything that you have. There's only 6 ways to write ratios. We have abbreviation. Sine is written this way, but we're always going to use these abbreviations. We have cosine, tangent, cotangent, cosecant, and secant like that then. Okay, so I guess a few observations that you'll kind of see on here is the sine theta and the cosecant theta are reciprocals. So that's one observation. Another observation based on the definition would be the cosine and the secant are also reciprocals of each other. And the last thing I kind of see on here is the tangent of theta and the cotangent of theta are also going to be reciprocal. So it's kind of, if you learn the sine, cosine, and tangent, and then you learn which ones are reciprocals, then you've got your definitions done then. And basically, theta is going to be one of the acute angles on this. And so basically, in a triangle, we're just going to be looking at the 6 trig functions of either of those acute angles. Okay, so I want to go to a couple of applets here and kind of show you just a couple of things here that are worth showing. This one right here is basically showing the sine. Okay, the sine is defined to be the opposite over adjacent. And what will happen on this is, as the angle changes, the ratio of the opposite and hypotenuse is changing. So, right now we have a very small angle. The sine is getting very close to 0. As the angle gets bigger and bigger and bigger, you're going to see that ratio increasing. Eventually, that angle will get close to 90 degrees. And the closer we get to 90 degrees, the closer we're going to get to 1 on that. So that's just an observation about the sine wave. Okay, we can also look at the cosine. The cosine is adjacent over hypotenuse. And again, what happens on this is this ratio of adjacent over hypotenuse is going to change as the angle changes. Okay, And the idea with this would be as that angle gets closer to 0, that ratio gets close to 1. And if the angle gets bigger and bigger and bigger as it gets close to 90, that ratio gets close to 0. Okay, and the last thing I want to kind of show you is the tangent. The tangent's opposite over adjacent. So the ratio is going to change constantly on this. As we get close to 0, the ratio of the side opposite, which is the one in green, to adjacent, is going to change. So as we get bigger, that angle gets bigger and bigger and bigger and bigger. You're going to see something kind of strange happening here. You're going to see that thing gets bigger and bigger and bigger infinitely. Okay, by the time you get to 89, you're already at 57.29, and it will get bigger infinitely. And as you get closer to 0, the tangent ratio gets closer to 0. Okay, so those are kind of some things that are worth showing. Another thing I want to show you is if you keep the angle the same, which I'm doing here, then the ratio is going to stay the same. So this is a tangent relating opposite to adjacent. So as we change these sides, and the angle doesn't change, look at this ratio. It's never going to change. That will be the case on all of these regardless. So your sine ratio is always going to be the same regardless of the size of that triangle as long as the angle remains constant. Okay, so that's kind of what that means. Okay, another applet that I want to show here is this. The sine is defined to be the opposite over the adjacent, or I'm sorry, the opposite over the hypotenuse. So when you're doing a sine, you're doing the opposite over the hypotenuse. What happens is this ratio, what you're really finding is at this particular angle, 32 degrees, the sine is about 0.53 because the opposite leg is 53% the hypotenuse. Okay, and as we change this angle, so I'm going to just kind of change this angle a little bit. Okay, now we got 51. Okay, what's going to happen is that opposite leg now is 78% of the hypotenuse, so therefore the sine is 0.78 approximately. If you want to look at a cosine, it can be thought of the same way. The cosine is adjacent over hypotenuse, so I'm going to move this adjacent side up. So the cosine of 51 is 0.63 because that adjacent leg is 63% of the hypotenuse. Okay? And then finally, the tangent is really a ratio of opposite to adjacent. So what will happen now, the reason that the tangent of 51 is 1.23, because this opposite leg is 123% of the adjacent leg. And as I change this angle, now we got tangent of 25.547. That just means this opposite leg is 47% this adjacent side. Okay, those are kind of a couple of nice things to look at to give you a little bit of a deeper understanding of what these relationships are. Okay, so we already kind of talked about this on the previous page. The cosecant is the reciprocal of the sine of theta. The secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. Okay, so next thing I want to look at is just some ways to help you remember this. The classic way to teach students is think of the sine as being, think of this word SOHCAHTOA. That's one way to think of this. This is the most common way to do this. So the sine is S, it's the opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. There's a lot of different ways to learn this. I've seen many ways over the years. When I started teaching trig, which would probably be maybe 1991, 92, I gave my students a contest to see who could figure out some funny way to remember this, and this is what one guy came up with. You have the sine, you have the cosine, and you have the tangent. If you write those down in that order, then you just remember this phrase: Oscar has a hairy old ass. So he was the winner. Okay. Of course, it's talking about Oscar and his pet donkey, of course. But anyway, that's another way that somebody taught me how to do that. I think our textbook teaches a different way too. So there's lots of ways to learn that. Okay, on the next page, this is kind of what you do, the exercise you do to learn this. So in this particular problem, you're given A is 3, B is 4, and these are sides, and we need to find C. So we find C by applying the Pythagorean theorem, of course. So we'll have C squared is equal to 3 squared plus 4 squared. That will give C squared is equal to 9 plus 16. So that will give C squared equals 25. Then you can square root both sides, so you get C is equal to 5. And again, this is a common Pythagorean triple. You may have already known that C was going to be 5. So what I'm going to do is I'm going to put this in this triangle. Lowercase a is opposite angle A. We use capital letters for the angles. So this will be 3, B will be 4, and then C will be 5. Okay, so what we're going to do is just look at these ratios. The sine is, and we could do this SOHCAHTOA if you wanted to, okay, or you could do Oscar has a hairy old ass for sine, cosine, tangent. Then we just do what it tells us to do. So if we're focusing on the angle A, the side opposite is this part. That would be the 3. And then the hypotenuse is the 5. So the opposite is always on the other side of the triangle. So if you're looking at A, this is the side opposite. 4 is the side adjacent. C is the hypotenuse. The hypotenuse is always the hypotenuse. So that ratio would be 3 over 5. Okay. If we want now to look at the cosine of B, everything changes. Now the side opposite becomes 4, the side adjacent becomes 3, and the hypotenuse is 5. So the cosine is adjacent, which is 3, over the hypotenuse 5. Okay, and this will always be the case if you do the sine of A and the cosine of B. Sine of A and cosine of B will always be the same. Okay, now the tangent, I'll go back to angle A and look at this. Okay, so if I look at this, the tangent's definition is opposite over adjacent. So that will be 3/4 like that. Okay, now the rest of them you can do reciprocals on. The cosecant is hypotenuse over opposite. So it would be 5/3. The secant is hypotenuse over adjacent. So it would be 5/3. And then the cotangent is adjacent over opposite. It's the reciprocal of the tangent. So that would be 4/3 like that. Okay, so you want to be able to take a right triangle and write out easily those 6 ratios. Okay, so that's example 1A. Here's example 1B. Okay, so again, we'll start this off the same way. We're going to use the Pythagorean theorem. So we have A squared plus B squared equals C squared. This time A is 2, B is what we're going to try to find, and C is 3 squared. So if we do this, we're going to have 4 plus B squared equals 9. We can subtract 4 from both sides of the equation to get B squared equals 5. Then we can square root both sides to get B is equal to the square root of 5. Okay, so we got that. And now what I'm going to do is just kind of go to my triangle and label everything. Okay, now this time I gave the sides. So the angles go like this. C is the hypotenuse, so the right angle is capital C. The angle opposite A will be uppercase A, and then the angle opposite side B will be uppercase B like that. If we go through and put these values in, A is 2, B is square root of 5, and C is equal to 3. So now we should be able to go through and write our ratios. So I'll do the same thing again. Oscar has a hairy old ass. Okay, or you can think of SOHCAHTOA. I just got to know how to spell it. Okay, all right. So sine of A. Again, we're going to look at A, and we're going to talk this out. So opposite A is 2. The hypotenuse is 3. So if you look at the sine A, that should be 2 over 3. Okay, now we're going to look at the cosine of B. So we focus on this angle now. So if we look at this, the cosine is adjacent over hypotenuse. So adjacent's 2, and then hypotenuse is 3. And one thing I said is in any right triangle, the sine of A and cosine of B will always be the same. Okay, and then we'll go back to angle A. Yeah, you can do these in any order you want to. So we've got angle A over here. And if I look at this and talk out the tangents definition, opposite is 2, adjacent is square root of 5. So we have 2 over square root of 5. You don't necessarily have to rationalize the denominator, but it's something that I'll continue to do some to remind you how to do this. So you just multiply by the square root of the denominator, and that will end up giving 2 times the square root of 5 over the square root of 25, which is 5. So what we have is these are the ratios for the sine, cosine, and tangent. Now you can do the reciprocals. The cosecant is the reciprocal of the sine, so that will be 3 over 2. The secant is the reciprocal of the cosine. That'll also be 3 over 2. The cotangent is the reciprocal of the tangent, so that will be square root of 5 over 2 like that. Okay, so that's how you write your ratios. It's a pretty simple thing to do, and it's an important starting point for trigonometry. Okay, on the next page, I will have you all do these 2 problems, and then that will wrap up this first video right here. So if you want to pause the video and then come back and resume when you're ready to check your answers, please do so. I want to mention real quick, because I just saw this problem number 1 had a mistake. That right angle should be C, that other one should be B. Okay, so I wanted to catch that before you go into doing your problem. And I've already got C equals 13. I found that mistake when I was working this. Okay, so if you want to check your answers, then you may do so. Make sure you did okay. Just check all of your ratios on this. See if you got that right. I did rationalize denominators on a few of them on the second example. And, you know, I don't always have to ask you for sine A and cosine B. I just do that to show you that they're the same. If you did cosine of A, then cosine of A would be something different. It'd be 12 over 13. Okay, so hopefully everybody did well on that. That will wrap up this first part of the video. Good luck, and that will get you started on trigonometry and the 6 trig functions. Good luck.